So I found a 1999 Mazak Impulse 30H for a good deal locally, and I decided to hook up the trailer and go have a look. The downside to taking a trailer to go have a look is that you can't bring back an empty trailer or the neighbors will know you're a quitter. So despite having no way to power it up and make sure it actually would power up, we loaded all 3.15 tons of it just as the sun went down and hauled it home, where it managed to sit all winter. When spring came around, we finally pulled it out from the tarp, rented a forklift, and started the process of moving it into the shop. It required disassembling part of the enclosure to get it fit through the overhead door. Once we got it on the floor, we used some drill rod to slowly roll it into position. This involved drilling an anchor and using a come-along to pull it into its final position. Once it was actually in place, we could start to assess what we had, and this machine had definitely seen a lot of use. There was surface rust on all of the precision bearing surfaces, but the worst part was the coolant and chips, which had solidified everywhere. After many days of scraping and then wiping some more, we had cleaned it up for the most part. The technique that we found worked best was working on it with a scraper to get most of the big chunks off, soaking it with a citrus-based degreaser, letting it sit for a while, and then scrubbing away with Scotch-Brite pads. Despite how bad it looked, all of the components were in pretty good shape, and after getting rid of the gunk and surface rust, everything looked pretty good. The grease feeding the 6 linear rails and the 3 ball screws had dried up completely at this point. So after we found the Mazak specific grease and filled up the grease supply system, it was moving under its own power again. As I said, this is a Mazak Impulse 30H, built in Japan in 1999. It's seen about 23,000 hours of production use according to the onboard timer. Technically, it's a drill and tap machine rather than a vertical milling machine, which means its primary purpose is drilling a lot of holes and then tapping them rapidly. The rapid speeds are pretty incredible because of its linear rails and beefy servo motors. In practical use, it's quite capable of milling as long as you keep in mind that it's a 30 taper machine. Its main features include a 10,000 RPM spindle that can do rigid tapping. It has a unique 10-tool automatic tool changer where there's a magazine on either side of the spindle which extend on pneumatic cylinders. One of the most unique features is the pallet changer system, where the entire table will rotate 360 degrees, allowing you to be loading one side while the other is cutting. Up to this point, we weren't actually sure if we would be able to transfer G-code to the machine. We knew that it had provisions for reading tapes, as in punched paper tapes, but transferring G-code via computer we weren't sure would be possible. After a painful amount of research and a lot of trial and error, we managed to find a non-standardized pinout for the RS-232 connector, downloaded a direct numerical control program, and set the CNC to receive commands. The memory on the Mazak is limited to a whopping 300 kilobytes, and we still haven't figured out the best way to increase the memory size or enable drip feeding. But for now we're able to transfer G-code and run programs on the CNC. That's where the machine is currently at. We are making chips and we have a few projects in the works. Subscribe if you want to stay updated, and if you have any questions about how we got the DNC set up or any machine specifics, or you just need someone to talk you out of buying that local basket case machine tool, leave a comment below.